The engineering design process is the formulation of a plan to help an engineer build a product with a specified performance goal. This process involves a number of steps, and parts of the process may need to be repeated many times before production of a final product can begin. A Euro component, or process to meet desired needs. It is a decision-making process in which the basic sciences, mathematics, and engineering sciences are applied to convert resources optimally to meet a stated objective. Among the fundamental elements of the design process are the establishment of objectives and criteria, synthesis, analysis, construction, testing and evaluation. The engineering design process is a multi-step process including the research, conceptualization, feasibility assessment, establishing design requirements, preliminary design, detailed design, production planning and tool design, and finally production. The sections to follow are not necessarily steps in the engineering design process, for some tasks are completed at the same time as other tasks. This is just a general summary of each part of the engineering design process. Research: a significant amount of time is spent on research, or locating information. Consideration should be given to the existing applicable literature, problems and successes associated with existing solutions, costs, and marketplace needs. The source of information should be relevant, including existing solutions. Reverse engineering can be an effective technique if other solutions are available on the market. Other sources of information include the Internet, local libraries, available government documents, personal organizations, trade journals, vendor catalogs and individual experts available. Conceptualization: once an engineering issue is defined, solutions must be identified. These solutions can be found by using ideation, or the mental process by which ideas are generated. The following are the most widely used techniques: trigger word, a word or phrase associated with the issue at hand is stated, and subsequent words and phrases are evoked. For example, to move something from one place to another may evoke run, swim, roll, etc. Morphological chart: independent design characteristics are listed in a chart, and different engineering solutions are proposed for each solution. Normally, a preliminary sketch and short report accompany the morphological chart. Synectics: the engineer imagines him or herself as the item and asks, "What would I do if I were the system?" This unconventional method of thinking may find a solution to the problem at hand. The vital aspects of the conceptualization step is synthesis. Synthesis is the process of taking the element of the concept and arranging them in the proper way. Synthesis creative process is present in every design. Brainstorming: this popular method involves thinking of different ideas, typically as part of a small group, and adopting these ideas in some form as a solution to the problem. Feasibility assessment: the purpose of a feasibility assessment is to determine whether the engineer's project can proceed into the design phase. This is based on two criteria: the project needs to be based on an achievable idea, and it needs to be within cost constraints. It is important to have an engineer with experience and good judgment to be involved in this portion of the feasibility study. Establishing the design requirements: establishing design requirements is one of the most important elements in the design process, and this task is normally performed at the same time as in the feasibility analysis. The design requirements control the design of the project throughout the engineering design process. Some design requirements include hardware and software parameters, maintainability, availability, and testability. Preliminary design: the preliminary design, or high-level design, bridges the gap between the design concept and the detailed design phase. In this task, the overall system configuration is defined, and schematics, diagrams, and layouts of the project will provide early project configuration. During detailed design and optimization, the parameters of the part being created will change, but the preliminary design focuses on creating the general framework to build a project on. Detailed design: the detailed or low-level design portion of the engineering design process is the task where the engineer can completely describe a product through solid modeling and drawings. Some specifications include operating parameters, operating and non-operating environmental stimuli, test requirements, external dimensions, maintenance and testability provisions, materials requirements, reliability requirements, external surface treatment, design life, packaging requirements, external marking, input machine. The advancement of computer-aided design, or CAD, programs have made the detailed design phase more efficient. This is because a CAD program can provide optimization, where it can reduce volume without hindering the part's quality. It can also calculate stress and displacement using the finite element method to determine stresses throughout the part. It is the engineer's responsibility to determine whether these stresses and displacements are allowable, so the part is safe. Production planning and tool design. The production planning and tool design is nothing more than planning how to mass produce the project and which tools should be used in the manufacturing of the part. Tasks to complete in this step include selecting the material, selection of the production processes, determination of the sequence of operations, and selection of tools, such as jigs, fixtures, and tooling. This task also involves testing a working prototype to ensure the created part meets qualification standards. Production. With the completion of qualification testing and prototype testing, the engineering design process is finalized. The part must now be manufactured, and the machines must be inspected regularly to make sure that they do not break down and slow production. See also, Applied Science, Axiomatic Product Development Life Cycle, Blueprint, Design, Design Engineer, Design Review, Design Science, Engineering, Engineering Analysis, Engineering Design Management, Ideal Final Result, Interaction Design, Marketing, New Product Development, Software Development Process, Systems Engineering Process, Traditional Engineering. References, http www.munlvedcusinitisabedefinitiONHTM, ABCDEFGH A. and Jones, J. The Engineering Design Process 2nd ed. New York, New York, John Wiley & Sons, Incorporated, ABCDAID, R. Jennison, L. Mashaw, L. Northup. Engineering, Fundamentals and Problem Solving. New York City, McGraw-Hill Companies Incorporated, 2002, Ralph, P., and Wand, Y. A proposal for a formal definition of the design concept. In, Littin, K., Loukopoulos, P., Malopoulos, J., and Robinson, W. Design Requirements Engineering, A 10-Year Perspective, Springer Verlag, 2009, pages 103 to 136. Wieders, P. Introduction to Finite Element Analysis. Retrieved from http www.svvtedu.mse 2094 Notebook and History HTML, ABET, Criteria for Accrediting Engineering Programs, Engineering Accrediting Commission, Baltimore, Maryland, 2003, Ullman, David G. The Mechanical Design Process, M.C. Graw-Hill, 4th edition, Eggert, Rudolph J. Engineering Design, 2nd edition, High Peak Press, Meridian, Idaho. www.hypocpress.com